Hi everyone, today in Integrated Math 1, we're going to go over Chapter 6, Lesson 5. Here are the objectives. Make sure you write them down in your notes. Alright, so this week we're going to be going over the various methods that we have been learning to solve systems of equations. As you can see here, we have a total of 5. 1, 2, 3, 4, 5. And these methods can all be used to help you. Some are better in certain situations than others. So graphing. We want to use graphing when we're trying to estimate solutions. And this is particular because we may not need an exact solution. We may just need to find it's around here. There's a lot of solutions, one solution, or no solutions. So that one's nice for that. Substitution. We want to use substitution if one of the variables in either equation has a coefficient of 1 or -1. Best times to use substitution. Elimination with addition. If one of the variables has opposite coefficients in the two equations, we just add them up and one of the variables goes away. Elimination using subtraction. If one of the variables has the same coefficient in the other two equations. Same idea as the first one. Then elimination using multiplication. If none of these coefficients are 1 or -1, and neither one of the variables can be eliminated by adding or subtracting the equations, then this is when we want to use multiplication. So let's look at our example 5. We want to determine the best method to solve the system of equations, and then we solve it. So, as we see here, first of all, our first option would be to graph, but I also see it's not ready to be graphed. We'd have to, because remember, when we're graphing, it needs to be in the form y equals mx plus b, and obviously we'd have to do a lot of work for that one. So I would recommend not graphing this one. Our next option would be substitution. Remember, when you do substitution, you want to have one variable that has a coefficient of 1. In this case, we do. We have the y right here. So that's perfect. So let's use substitution for this problem. So we have in our second equation 4x plus y, which is equal to -6. We have to get y by itself in order to use a substitution, because we have to say y is equal to whatever that may be. Minus 4x to both sides. So I have y is equal to -4x minus 6. So now every single time you see y in our first equation, it's going to be -4x minus 6. So 3x plus 5y is equal to 4. 3x plus 5 times now -4x minus 6 is equal to 4. And as you see here, we're going to need to use a distributive property. So we have 3x minus 20x. 5 times -6, -30, which is equal to 4. We combine like terms with our x's. 17x, -17x, minus 30 is equal to 4. Get your variable by itself. Plus 30 to both sides. -17x is equal to 34. I'm going to keep on going by dividing -17 to both sides. And then I know that x split is going to equal -2 here. Alright, because 34 divided by -17 is -2. So I've solved for one variable, but I am not done. I need to find out what y is equal to. have to find your ordered pair. Right now you only have half of your ordered pair because you only have x. So now let's choose an equation to plug it into. I like 1 because I see a negative here. I'd rather not deal with that. So I have 3x plus 5y is equal to 4. Every single time I see an x, it is now negative 2. And this is using substitution. Plus 5y is equal to 4. 3 times negative 2 is negative 6, plus 5y is equal to 4. Keep on getting y by itself. 5y is equal to 10. Divide 5 by both sides. Y is equal to 2. Make sure you leave it as an ordered pair with an x and a y. Our x is negative 2 and our y is 2. There's our solution.